Welcome to homework.
So here in this problem it is given that the steam enters an adiabatic diffuser at pressure P1 150 kilopascal and temperature T1 is 120 degrees Celsius, and the velocity V1 we are given as 550 meter per second, and the exit pressure is given as P2 we are given as 300 kilopascal, and we have to calculate the minimum velocity that the steam can have at the outlet, that is V2 we have to calculate, and that to minimum. So to proceed with the solution, first let us see the TS diagram of this process. So this is the state 1 and this is the state 2, and because it is asked we have to calculate the minimum velocity, so we have to take the process to be as isentropic process. There should be no irreversibility in the process. So now we can proceed with the solution. So P1 we are given as 150 kilopascal and T1 is 120 degrees Celsius. Now we'll be using the table A6 to find the required input data. So according to this pressure and temperature, we can obtain the value of H1 and S1, specific entropy and specific enthalpy. So H1 will get it as 2711.4 kilojoule over kg, and specific entropy will get it as 7.2699 kilojoule over kg Kelvin. Now P2 we are given as 300 kilopascal, and T2 we don't know the value of T2, but we know S2 should be equals to S1 because we have assumed to be as isentropic process. So it will be 7.2699 kilojoule over kg Kelvin. Now again, by using the same table we can obtain the value of specific enthalpy at state 2. So H2 will comes out to be as not nearly, exactly 2845.7 kilojoule over kg. Now here in this question we will be assuming the diffuser as our system, and which is a control volume since the mass crosses the boundary. So now we can apply the steady flow energy equation, that is energy in minus energy out. It will be equals to change in energy of the system, the rate of change of energy system. So in the process it is a steady process, so we can say that this value would be 0, and energy in we have m dot h1 plus v1 squared divided by 2, and if we put this value towards the right side, so we'll get energy output, and energy output is m dot h2 plus v2 squared divided by 2. So from here we'll get the value of v2, we'll get the expression for v2 as v1 square plus 2 times h1 minus h2 to the power 1 by 2. So we have all the values here, we can plug all the values in this equation. So v2 will be, this one is 550 meter per second whole square plus 2 times h1 minus h2. So h1 is this one, sorry, h1 is this, so this is 2711.4 kilojoule over kg Kelvin, minus, and this is h2 is 2845.7, and the unit is kilojoule over kg, kilojoule over kg. But here we have to convert the unit. We know that 1 kilojoule over kg is equivalent to 1000 meter square plus meter square by second square, and to the power 1 divided by 2. So after solving this, we'll get the V2 as nearly 184.1 meter per second. So this is the final solution I hope you got the problem. Thank you.